Hey guys, let's get started. This is 8th grade math. Unit 3, Lesson 3, Lesson Representing Proportional Relationships. And for this assignment, you are required to take notes. Get your pencil and paper. Label the top of your paper 8.3.3 Lesson Notes. After this lesson, you are required to turn in your notes. So do a good job. Remember, you're probably not learning if you're just listening and waiting for me to show you the answers. Make sure you do it yourself. Okay, here we are. Problem 1, and this is problem 1A. Find the value of each product mentally. Remember, the word product means the result after multiplication. So the product is the answer after you multiply. 15 times 2. Hurry up, what's the answer? Type in your answer. 15 times 0.5. Type in your answer. Remember that multiplying by 0.5? Well, that's the same as multiplying by 1/2 because 0.5 equals the fraction 1/2. So what happens when you multiply the number 15 times 1/2? Let me help you with this one. Remember that multiplying by 1/2 is the same as dividing by 2. So that's the same as 15 divided by 2. Okay, good job, guys. Do you want to see another way to do that in your head really quickly? 15, that little dot means to multiply. 15 times 0.5. Well, what if we did 15.5 very quickly in our head? 5 times 5 is 25, and 5 times the 10, that's 50. So 50 plus 25, I can just kind of do that in my head, that's 75. So 15 times 5 is 75. Now just move the decimal point over one spot to get your answer. I have a few tricks of doing these in my head. Okay, let's keep going. 15 times 0.25. Well, remember, multiplying by 0.25 is the same as multiplying by 1/4. Don't forget that the decimal 0.25, that equals the fraction 1/4. Okay, do the math in your head. And then 15 times 2.25. Well, that's the same as multiplying by 2.25. Anyway, I don't know if that helps you or not, but you're supposed to do these in your head. Okay, if you multiplied 15 times 2, then you know that answer is 30. And if you multiplied 15 times 1/4, then you know that answer would be, let me think, 15 divided by 1/4. What goes into 15 4 times? Nothing. Nothing at all. Let's just do some math like this. 15 divided by 4. 4 goes into 15 3 times, and that leaves over 2/4. And 2/4 is equal to 1/2, so this answer is 3.5. Did I get that right? You guys better check my math. Sometimes I make mistakes. Anyway, so here is the answer when I multiply 15 times 0.25. And I have the answer for when I multiply 15 times 2. So what about when I multiply 15 by 2.25? Well, you can just add them up. It's the same as 15 times 2 plus 15 times 0.25. So the answer is going to be 30 plus 3.5. Okay, hey, if you don't believe me, then do it yourself with pen and paper. But it says to find the product mentally. So just try to figure it out mentally. Okay, you don't need to do this in your notes because you're supposed to do it mentally, but I'd like to see your answers here. Let's keep going. This is problem number 2. Problem number 2, you do need this one in your notes. So you got your note paper here? It starts with problem 2. Write that down at the top of your paper. Let's see what the problem is. Jada and Noah counted the number of steps they took to walk a set distance. Jada took 8 steps while Noah took 10 steps. Then they found that when Noah took 15 steps, Jada took 12 steps. Okay, that's a description of the problem. Let's go ahead and take notes on that. Okay, go to your note paper. Now we've got 2 people they're talking about, so write that in your notes. There's Jada and Noah. When Jada took 8 steps, Noah took 10 steps. They told us that. Then they told us that when Noah took 15 steps, Jada took 12 steps. So do you think this is a proportional relationship? If it is, then these ratios are equal. 8 steps of Jada's to 10 steps of Noah's. Does that equal 12 steps of Jada's for 15 steps of Noah's? If these are equal, then it is a proportional relationship. Let me simplify the fractions to find out. This simplifies to 4/5 and 12 over 15, Let's see if they're equal. I should have put a question mark here because I'm telling you they're equal. That's not what I meant. I meant, are they equal? Anyway, this also simplifies to 4/5. Ding, 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 ding. We have a proportional relationship. So right off the bat, we can find our proportional constant. It means for every 4 steps Jada takes, Noah takes 5. Now don't forget, that's Jada in the numerator and Noah in the denominator. If we want to write our equation for this, it's going to be y. Y is going to be Jada. Y equals our constant of proportionality times x. And the x is going to be Noah. And then what is the k? Well, we found it right here. Okay, let's look at the next part of the problem. We took notes on the first part, but let's keep going. Now it tells us the equation. Let x represent the number of steps Jada takes. Uh-oh, I think I have that backwards in my notes, don't I? Yeah, I put Jada as y. I'm going to erase that. If you have it in your notes, just draw a line through it. You don't have to go get an eraser. Just, you know what? I'll draw a line through it too. Let me do the same thing. I'll draw a red line through it. So scratch this part here. And then this constant of proportionality would be upside down. And these would be upside down. So they're telling us, let x represent the number of steps Jada takes. So that's x. Oh no, it looks like I crossed it out. I really want to have nice notes. Here we go. X equals the number of steps Jada takes, and y equals the number of steps Noah takes. And then go back to your GeoGebra page. They told us this equation. Well, they didn't even need to tell us. We could have figured that out on our own. I don't know why they even need to tell us, but they tell us that y equals some constant of proportionality, which is the number of steps Noah takes, because he's y. It's always y on top and x on the bottom. So here is where I'm getting it from. For every 8 steps Jada takes, Noah takes 10 steps. Listen again. For every 8 steps Jada takes, Noah takes 10. And why did I line it up this way? Before, I had the opposite. Now I have 10 in the numerator and 8 in the denominator. Why is that? Because I have y for Noah, and slope is rise over run. So let me just draw an axis right here to help you remember. Rise is the y value. Run is the x value. And this problem told us that the y-axis is going to be Noah. Go ahead and write this in your notes. It told us that the x-axis is going to be Jada. So for every 8 steps Jada takes, Noah takes 10. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that gives us our slope of the line that we're going to find for this proportional relationship. So that's how I got 10 over 8. Simplify that down, and the slope is 5 over 4, which is what they told us, but we can calculate that ourselves. They told us that here, but we can calculate that ourselves because of the data they gave us. It says right here, for every 8 steps Jada takes, Noah takes 10. For every 8 steps Jada takes, Noah takes 10. Okay? Okay, great. Now, this part. Create a table that represents the situation with at least 3 pairs of values. 3 pairs of values. Okay, let's do the table in our notes. You have to do the table in your notes. The x value is Jada. The y value is Noah. And I think it's a good idea to write down the names as well as the x and y until you're so good at this that you can keep it straight. So we want to just put some data points here. They've already given us some data points. When Jada takes 8 steps, Noah takes 10. When Jada takes 12 steps, Noah takes 15. Now we just need to come up with another data point. How about, do you want something larger or smaller? How about when Jada takes, I don't know, 20 steps? When Jada takes 20 steps, how many steps does Noah take? How many steps does Noah take? Okay, let's write the equation to help us. So Noah is y. Y equals the constant of proportionality. Oops, 5 over 5. No. 5 over 4. That's what it is. 5 over 4 multiplied by the number of steps Jada took, which was 20. Okay, remember what this constant means. It means for every 4 steps Jada takes, Noah takes 20. And that makes sense here, doesn't it? Because if Jada takes 20 steps, then how many steps does Noah take? It's going to be 5/4 times 20. Can you do that in your head? That's why we practice those problems. 5 times 20 is 100, and you still have the denominator 4. That equals 25. So come back over here. Fill it into your table. I'll erase my question mark there. When Jada takes 20 steps, Noah takes 25. Okay, go ahead and fill that out in your notes so that you can keep all your information straight, but you still have to fill that out here too. So when you do your GeoGebra page, don't forget to put your information in. You have to take notes and do the work in GeoGebra. But you know what? After you take notes, it's simple to put it in, isn't it? Okay, let's go to the next part. Graph this relationship and label the axes. Aha, look at the axes. They're totally blank. Nothing here. Okay, so what do you want to label these as? Well, the x-axis is Jada. Okay, let's use the GeoGebra tools now. And the x-axis, oops, right here is Jada's steps. The y-axis is Noah's steps. And we need a scale. Look at the points we have. What range do we have for y values? We have from 10 to 25. So what can we use for scale on the y-axis? How many points are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we want to go up to 25? I guess a good scale could simply be every tick mark is 2 units. Every grid square is 2 units, like that. Okay, so we're going to label that with GeoGebra tools. Get the text tool here, and then you're going to actually type in the scale yourself. So the first tick mark is 2 units. And the second tick mark is 4 units. And the next tick mark is 6 units. Use the text tool and go all the way to the top. I think you better fast forward through this on the video. Do you know how to change the playback speed when you watch a video? Go to the settings wheel. Then you can find playback speed. Increase the playback speed to about 1.5, and you can watch me in fast forward, which is a lot better because the speed at which I type is really slow compared to how fast you can learn. Okay, 18, exhausting, isn't it? 20. Okay, great. We went from 0 to 20. So that is going to cover, oops, wait a second. 25. Oh no, I need to go further. Oh no, I think I made a mistake. I need just a little bit more. I needed to go up to 25, but I'm out of space at 22. What should I do? Should I count by 4s? That's going to really cram in my scale. Should I count by 3s? I don't want to count by 3s because then I can't put it on the even numbers. I wonder if I can move this graph. Let me try. No, it doesn't move. Okay, here's what I'll do then. I'm going to clear that. And I'm going to start again. Noah, Jada, and okay, every 2 lines will be 6 units. Let's do that, okay, because we need all of our points to fit, but I want even numbers. So every 2 lines is 6 units. Oops, right there, 6 units. And then 2 lines more is another 6 units, so that's 12. This is how I'm going to do my scale. What are you going to do? Do you have another idea? 24. Oh, it goes up way too fast, doesn't it? Okay, whatever. 24 plus 6 is 30. There, that goes there. Let me make it a little nicer. This 12 goes here. Oops. Now maybe you want to count by 2s, 3s, whatever, it's your choice, but if you run out of space at the top of the graph, then you have not chosen a good scale. So I'm going to use this scale for now, although it's going to really cramp my graph. Now for Jada, we need to go from 8 to 20. We need to go up to at least 20. And I think that's going to be easy to fit on the x-axis because it's a wider than the y-axis was tall. So let me go back to counting by 2s. There's 2, 4, 6. Let's skip some. Here's going to be 10. I'm going to skip a few numbers to save time. 10, 11, 12, 13, 14 here. Now, if you're going to skip yours, go ahead, but I'm going to be checking it carefully. So check yourself before you turn it in. Don't make any mistakes. I am a very picky teacher, and I want your axes labeled and scaled beautifully. Oh, I already have a mistake. Look, I'm talking. I was going by 4s, 10, 14, 16. Man, just when I started chit-chatting, I made a mistake. Let me delete those. Delete. No, dang it. Okay, trash can is the delete button. See, you better be watching this video on fast forward, or otherwise you're going to be spending way too much time looking at my mistakes. Okay, 14 plus 4, that's 18. That's what I meant. And then this next point is 22. Let's stop there. That's enough for our scale because Jada's maximum data point is only 20. Create a table. Yeah, we got that. Graph the relationship and label the axes. Okay, well, we have the axes labeled and the scale is drawn. We have Jada and Noah. It's kind of messy though. I don't want you to turn in your messy work like this. So please go ahead and move over these points so that I can really see it clearly. There, okay, that looks good. Now we're gonna graph the relationship, get the point tool, and put these data points on. When Jada takes 8 steps, Noah takes 10. That's about right here. Okay, when Jada takes 12 steps, Noah takes 15. So 12 to 15, that's going to be about... Uh-oh, look at that. I have a mistake here too. Oh no, you guys. Looks like I cannot count and talk at the same time. I went from 12 to 24. Am I nuts? I'm counting by 6. Every 2 grid marks is 6 units. So 6, 12. This should be 18. This goes up here. This 30 goes up here. Oh man, why didn't you guys tell me that? I hope you check your work. Don't trust me. Never trust the teacher. Okay, here's 18. I found my mistake. Okay. Now, where was I? For every 12 steps Jada takes, Noah takes 15. So plot that point. Point tool. 12 steps for Jada is 15 steps. That's going to be right about here. Here, I think. Okay, I'm just double checking a little. For every 20 steps Jada takes, Noah takes 25. 20 steps for Jada is here, and 25 is just above that line, right there. Okay, we plotted the points. If we plotted them correctly, then they will all lie on a straight line originating from the origin. The origin is 0.00. Look at that. I did a pretty good job. They're on a straight line. If there were points off of the line, then you did a bad job or you made a mistake. So go back and check it if yours do not line up. This is a proportional relationship. They will line up. Okay, you did it. Your graph needs to look like this. How can you see or calculate the constant of proportionality in each representation? And what does it mean? Okay, hold on. What are they talking about each representation? Here it says each representation. What's that? Well, the representation was the data table and the graph. So what they're teaching you is that these proportional relationships in the equation y equals some constant times x, you can represent that data in 2 ways, a data table or graph the data. So those are the representations, a table or a graph. So how can you see or calculate the constant of proportionality in each representation? It says, look at these words here. How can you see or calculate? Well, from this graph, I think we can see the constant of proportionality. All we need to do is see the change in x for every change in y. And we already saw that it is 8 units over and 10, was this 10 units up? Just a second, I don't remember. 10 units. That's where this data point comes from. 10 units up was about right here. So the K is the slope of the line. The slope of the line equals rise over run. That means the change in Y value for every change in X value. So change in Y, that triangle is called a delta. It means change. Change in Y divided by change in X. Now see it on the graph. The Y value goes up by 10 every time the X value goes over 8. That's what we call rise over run. And that makes this proportional constant. You can see that everywhere on the graph. So the next point also goes up 8 and over 10. Well, it's not 8 here because this is a proportion. So this actually goes up from 10 to 15. See, it went from 10 to 15. So from 10 to 15, that's a change of 5 units for Y. Y went 5 units up. And then the X value went 4 units over? Yeah, 4 units over for the X value. From 8 to 12 is 4 units over. Please look again carefully. If you don't understand yet, make sure that you do. This is 8 units run, and this is 10 units up. This is 4 units run and 5 units up. So no matter where you look on the line, they are proportional. The rise and run are proportional. Proportional, 10 over 8, which is also equal to 5/4. So that's how we can see the constant of proportionality on the graph. Now, what about on the other representation, which was the data table? How can we calculate the slope of this line? How can we calculate K? Well, K is going to be the change in Y divided by the change in X. So let's do some math here. The change in Y, I'll write that down for you, even though I put it many times. Go ahead and do this in your notes too. Next to the data table, write this down. K equals the change in Y divided by the change in X. So pick 2 points. How about 10 and 15? These points right here, 10 and 15. And let's call this Y2, and let's call this Y1. That means here is X2. Go ahead and write this down in your notes, and this is X1. So the change in Y divided by the change in X, that equals Y2 minus Y1 divided by X2 minus X1. Don't forget this equation. It's very simple, but you'll use it again and again and again all through high school. So the change in Y is just subtracting 1 point from another. 15 minus 10. 15 minus 10. The change in X is subtracting the points in the same order, 12 minus 8. Make sure you keep it in the same order or else you'll make a mistake. Okay, 15 minus 10 equals 5. 12 minus 8 equals 4. So that is how you can calculate the slope with the data points. Let's type in the answer here. You have this in your notes, right? I put this next to the data table, but I want you to put it in your notes. Should I do it again to show you? Empty note. Oh no, what happened to my notes? Oh, it's disappeared. Well, you better have it in your notes. Yours didn't disappear, did it? I guess I better start again. No problem. You have your notes. And in your notes, you better make sure you put how to calculate K from data points. Okay, this needs to be in your notes. And call that slope. slope of the line, or you can call that the proportional constant, constant of proportionality. My pen tablet's really bad. Proportional constant. I'm not going to write it out. My pen tablet's really bad. You'll have to find it yourself. Okay, type in your answer. I told you the answers, how you can see it on the graph and calculate it from the data points. Now you type in your answer here and explain it to me. Do you want me to help you with that? Okay, I will. You can see the rise overrun on the graph, which equals the constant of proportionality. And you can calculate the constant with the data points by finding the change in y for every change in x. Okay, type in your answer. Next question. Explain how you can tell that the equation, description, graph, and table all represent the same equation. Well, that's a big question. Explain how you can tell that the equation, description, graph, and table all represent the same situation. Okay, they gave us 4 different ways to represent this same situation. And that's the point of this lesson. The same situation can be described by an equation. An equation takes the form y equals k times x. That's the equation. The description of the problem was right here. Here's the description. Jada and Noah counted the number of steps. The graph is here. We graphed it ourselves. And then the table, the data table, we filled it out. We're using the description of the problem. So do you see that what they're teaching you is there are 4 different ways to show a proportional relationship. The description of the problem can tell you that it's a proportional relationship. You can have an equation of the line. In this case, they gave it to us, but we could have calculated that. So that's 2 ways. You can show a proportional relationship by making a table of data, a data table. And you can also show a proportional relationship by graphing it. You can graph this equation or graph those data points. But how can you tell that all 4 of those represent the same situation? So here's what's really important. All 4 of those represent the same situation if the slope is the same. If all 4 have the same constant, which is the slope of that line, then they represent the same situation. In this case, the description, equation, graph, and data table all yield the same slope. All show the same slope? How should I say that? All show the same slope of the line. The slope of the line is the proportional constant. Don't forget, sometimes I call it slope, sometimes I call it the proportional constant, sometimes I call it just constant. Anyway, they're all the same thing. Later on in math, you can call that slope of the line too. Okay, type in your answers, and let's go on to the next problem.